Hola. Hello, good morning. My name is Ricardo Molina. I'm the manager of the Material Joining Department in the R&D body in white area of Gestamp. So thank you very much for coming today. We'll talk about the 3D printing solution for lightweight body structure. Gestamp is an industrial company with innovative solution in chassis, in body in white, and in mechanics. We have R&D centers around the world, in North America, South America. Many of them are here in Europe, and also in China and Japan. So we have the performances to bring an idea from the beginning, till the end. And we have very add-valued products in body in white, like bumpers, cross-car beams, or structure. We have also a huge portfolio in chassis products and mechanics. Just to give you a footprint and an idea about Gestamp, we have about 100 plants around the world, production plants for stamping parts for automotive sector, and we have 12 R&D centers. Let's talk about the challenges and why we have to improve our products in the automotive sector. One of the things that make us move ahead and develop new technologies is the new challenges in the CO2 limits that the governments and the market is demanding. So it's clear that in Europe in 2020 we have to reach the limits of native 5 grams per kilometer, and United States will be following us in 2025. This is a forecast. Probably something will be changing in the next years. So how can we achieve that? To do that, we can reduce the consumption of the car. Is due to the powertrain, aerodynamics, but the 23% of the consumption is due to the weight. So there is a potential there to develop new lightweight technologies to reduce the consumption and get the CO2 limits. So what can we do in Gestamp? We have more than 50%, we are producing more than 50% of the stamped parts that are assembling the car. So we can develop a lightweight structure that will reduce the consumption. We have in body in white, we have from 25% to 30% of potential reduction in the weight. In chassis, we can do the same up to 50%. This is one branch, the CO2 limits, but we have another challenge. It's the new severe safety regulation that are coming in the next years. In the beginning, 1994, we started with the NCAP. In 2003, we had the first light crashes, where we started to work in the improvement of the performance of the car. Nowadays, in 2012, we have the small overlap test. Basically, we are crashing the car against a structure, and we are checking how the car is deformed, and we are evaluating the damage in the own car. But this is going to change. So we are moving in 2020 to the new compatibility test. In this case, what we are doing is not only checking what is happening in our own car, but what are we doing to the other car. So what's the issue now? That we have to change again all the technologies, because in case of having a strong or heavy car, those cars that are now having pretty good results in crashing, in the future they will not, because they are damaging a lot the other cars. So what do we need? So it's clear that we have to reduce weight due to CO2 limits. We have to improve the performance of the car due to the new crash test. And the automotive sector is continuously asking us for reducing costs. Then it's necessary, it's a must, to have new technologies that could change the trend of adding costs to reduce weight and performance. So what we need, the market needs safer car, so we have to develop new innovative products and performance. The market is asking for lighter cars, so we have to have new materials and technologies application, and the market needs to reduce our costs, and we have to develop new advanced processes. But some issues, so new technologies to get less weight. But what's happening when we're just reducing weight without taking in account that we have to improve the performance and improve the crash and reduce the cost. If we're just reducing weight, then we see that we have problems with the stiffness of the car, vibrations and noise that are inside the car are not good if we are just reducing the weight and the thickness of the parts. What is happening if we are just reducing the reinforcements of the car and the patches? That probably we will have problems with the crash in crash test, and we are reducing the performance. How can help additive manufacturing and solution to solve those problems? We think that the additive technology is a fast way to improve the performance of the car, because we can use it as a new technology to reach those new challenges. But in the automotive sector, perhaps it's not, the additive manufacturing is not the only solution, but it's a solution if we combine with other existing ones. Because we have the problem of the break-even of the high volume production, the low volume production, and the cost. Nowadays, the additive manufacturing probably is too expensive to use it for high volume serial production. In our plants, we are working in serial manufacturing with hot stamping, roll stamping, cold stamping. Those technologies has well proven, they are well proven to be produced and to use in high volume production with low costs. But then we have taken the additive technology and we have developed a new technology called TPP. With this technology, we're able to move the break-even point to the high volume side of the graph, but using the additive manufacturing that is normally for low volume and higher cost solution. What are we doing? What's TPP? TPP is we are just adding powder metal lines melted by a laser beam and welded to the part that we want to improve. That's so simple. So it's fast and it's not so expensive. It's cheap, and with only this technology doing that, we are able to achieve the same performances with mass saving. We are able to improve the stiffness of the parts, and we're even to reduce or remove completely patches or reinforcements in parts, or even locally reduce the thickness of the parts. About stiffness, what does it mean? So if stiffness, we adding TPP lines, we see how the curves when testing the parts are increasing the stiffness around 3 or 4%, and even the load capacity. And we think it's very important to have the right material at the right place. It means that we're adding the TPP solution right there where the parts need it. Let's see it in a sample, in case study. In the left side, in the left picture, we will see a patch, a standard solution where we need these patch, these reinforcements in the side of the car to improve only the stiffness. But in this study, let's see how can we reduce that. We focus on the points of the patch that are really working to improve the stiffness, and we simulate how can we reduce the patch to the minimum expression, but maintaining the stiffness behavior. We are doing the same procedure with all the patches and reinforcements. We see where we have to apply material with the same stiffness behavior, and then we are doing with TPP technology. We see in our test that we are able to get even 140% more stiffness than without the patch. And not only that, but if we see the weight, the patch is 500 grams, 600 grams. This is one side, one hand. We have two hands. At the end is 1 kilogram that we're adding to the car. If we remove it and we use the TPP, we need only about 200 grams, 100 per hand. So we are improving the stiffness and reducing the weight using additive technology. We have stiffness, but we have also energy absorption that we need to fulfill with the new crash requirements. TPP is also increasing the absorption of energy in the car, up to 35%. The same, we have to apply, to put the right material on the right place. In this case, adding TPP in certain areas of the parts that are involved in crash, we're improving the energy absorption. A case study just to show you how it works. In this case, it's a sample part. We are adding there a couple of TPP lines, and we'll see in the simulation how the part is really improving in energy absorption more than 50% and in the force peak. But okay, let's see how it works in real parts. It's loading. So we have a side impact beam here. The standard side impact beam, normally with the standard solution is adding a patch. When adding a patch, we are, adding weight, what is not good, but we are improving the energy absorption, what we are needing normally when adding patches and in this case. But if we remove the patch, so we save weight and we use the additive technology, the TPP, we see how are we even improving the energy absorption if we compare with the patch solution and reducing the weight. Another time we are able to get less cost, less weight, better performances. And if we have a look to all the parts that we are producing, all the products that we are producing in our plant, we see the potential that we have to use the additive solution to existing parts. Next step that we like to point out here is that the TPP could be also used in new materials that are coming, like aluminum alloys. That we believe that the additive solution, additive manufacturing will come more and more as long as the production costs of the additive solution are reduced. We have to improve the cycle times. How are we producing parts with additive solution is too slow yet for the automotive sector. And another good solution using this is that we will be able to do a basic standard part, will be the same around the world, the same production, the same drawing, but we can adapt those parts to the requirements of every market, just finishing the parts on site using additive solution. Summary, finishing this presentation. Summary, of course, we have the challenges in CO2. We have limits we have to fulfill. We have challenges, new challenges in crash. There are new safety regulations that we have to fulfill too. And the market is demanding that we have to do a miracle here because they need less weight, less cost, and better performance. So the only way to go on in this market is with new technologies. But the additive manufacturing, we are thinking what's the right approach to the automotive sector. We know that stamping technologies are optimized in cost and time. So the ratio cost-weight using the current stamping solution are really good. And the additive technology as is too slow and expensive. So we think that the solution is use the additive technology over stamped parts to improve them, to improve the performance, and get new parts with less weight and better performances. If you see that to this graphic, normally in 30 seconds we have to have a part to send to customer. Only 30 seconds, and the part must be done. So we think that instead of using just additive manufacturing, that it takes a long time to produce one part, it's better to use stamping parts and ending those parts with additive solution that could give us the performances that the market is demanding. Thank you very much.